Next will be dividing radicals. So if a and b represent non-negative real numbers, then the square root of a over b is equal to the square root of a over the square root of b. So if you have a fraction inside of a radical, you can actually break it up to where the radical is over just the numerator and the radical is just over the denominator. So that way you can deal with smaller problems. This also works in reverse. So if you have a radical divided by another radical and they're the same index, then you can turn it into one big radical with the fraction on the inside. So there's an example here for you to look at. I'm going to let you look through that one on your own. And we'll do these examples here at the bottom. Again, if you feel like you already know this would be a great place to pause the video. Try these 3 problems and then come back and see. All right, so on this first one here, I've got a radical over a radical. The radicands look like they're related to me, 48y to the 9th and 3y to the 3rd. So I think probably the easiest way to deal with this is going to be to turn it into one big radical with a fraction on the inside. And then I can simplify that fraction. Now, when you do this, you need to make absolutely sure that it's clear that the whole fraction is inside your radical. Oops, that was supposed to be a 9 and I wrote a 6. Here we go. Okay, so now that I've got it all under one radical, I can go ahead and do this division that's in here. 48 divided by 3 is 16. Y to the 9th divided by y to the 3rd. The rule on that is you subtract them. So 9 minus 3 would be 6. And then finally, I can deal with the square root. So the square root of 16 is 4. And the square root of y to the 6th, if I wrote out y to the 6th long ways, I would have 3 pairs of y's. So this would be 4y cubed. And that would be it. Okay, similarly on that second one, again, if you had chosen not to pause the video before to try all 3 of them, this may be a good time to pause and try this one. All right, once again, I want to rewrite this as one big radical. I'm going to make sure that the radical shows that the entire fraction is inside. So I'm making sure that the little cusp down here goes all the way to the bottom. If it doesn't, then I'll extend it like I did on that first one. Okay, once I've got it written as one big radical there, then I can simplify the inside. 24 divided by 3 is 8. And x to the 7th divided by x to the 3rd. Once again, the rule is to subtract the powers. So 7 minus 3 is 4. And then I could simplify the, the radical then. So the square root of 8 would simplify into a pair of 2's and another 2. So I'd have a 2 on the outside and a 2 on the inside. And the square root of x to the 4th written out long ways would be 2 pairs of x's. So that would be 2x squared on the outside, square root of 2 on the inside. Okay, now for the third one. Once again, it looks to me like there's a relationship between the radicands in the numerator and the denominator. So I'm going to write it as one big radical. And then simplify the inside. And once again, I want to make sure that my radical goes all the way to the bottom of the fraction. So mine didn't quite make it this time, so I just extended it a little bit. Okay, now inside 18 divided by 3 is 6. X to the 5th divided by x would be x to the 4th. And then I would just need to take the square root. So the square root of 6, there will be no pairs of like factors for 6. But the square root of x to the 4th, written out long ways, there would be 2 pairs of x's. So that means I could take out an x squared. And this would now be simplified.